We've made it to the end of the third week. God bless you all and hallelujah. So our last class for this week on Friday, April the 17th is from 12.4 on vectors, and that starts in your book on page 596. Now what you're going to see with vectors is if you can see the vector that goes from A at coordinates x1, y1 up diagonally to B at x2, y2 with the arrowhead on the top is a directed vector, but we're going to work with it just as though it were a right triangle hypotenuse. But it's just that it has a direction where before a hypotenuse had no direction. So to get from A to B, we can go horizontally over A, which would be x2 minus x1, and then up vertically B, x2 at y2 minus y1. So we can think of it in terms of the components, horizontal component A and vertical component B, and the whole vector going directly from A to B. Now for example 1, we want to find the vector that goes from 3, 4 to 5, 1. And notice that the arrow is pointed at the end at 5, 1. So the horizontal component is 5 minus 3, or 2 to the right. The vertical component is 1 minus 4, because 1's where it ends up, minus 4 where it starts, so that's down 3. So to take that vector and slide it to the origin, which you can always do with a vector, is slide it so that it keeps the same orientation. We would be going from the origin down 3 and right 2, or the vector would have coordinates of 2, negative 3. So you see, we still treat it just like a right triangle, except the hypotenuse is the directed vector. Now example 2 says, describe each vector by stating its magnitude and direction. Again, remember the hypotenuse. So the one we just did, 2, negative 3, well, we did one similar to that. And we did 2, negative 3, but let's do this one as, okay, so we have an x component of 2, a y component of 3, so the vector squared, same as the hypotenuse squared, is 2 squared plus 3 squared equals 4 plus 9, or 13. V is equal to the square root of 13, or 36. Now that's the magnitude of it. Now to get the direction, we can always just take the inverse tangent of the y over the x, and we'll account for the signs in another way. So alpha is the direction part of the vector, which will be inverse tangent of 3 over 2, which is 56.3. Now the way that we put that all together is we say that vector has a magnitude of 3.6 at 56.3 degrees below the positive x-axis, and that's how we count for it going down. Now in part B, let's look at a vector that's negative 3, 3. And we see from the origin we go 3 left and then up 3, and the vectors from the origin up to the top of the up 3. So again, the magnitude is the square root of 3 squared plus 3 squared, which is the square root of 9 plus 9, or 18, and that's factored out as square root of 9 squared of 2, or 3 squareds of 2, which comes out as 4.2 for a magnitude. Now again, the alpha is the inverse tangent of opposite over adjacent, and we're not going to bother with sign here. We do that at the end. So alpha is equal to inverse tangent 3 over 3, which is always 45. So the vector V is equal to 4.2 of a magnitude at 45 degrees above the negative x-axis. And that's how we account for the sign of the negative 3 on the x. Okay, so for example 3, a boat is traveling 20 degrees west of south. Now remember, we start at south, which is straight down from our map coordinates, and we go 20 degrees up towards west, which is on the x-axis to the left. So notice the 20 degrees on my figure, and then since it's going to make a right angle with the x-axis, the inside the angle, triangle angle is 70. So that's how I can get inside the angle from the given directions. And we know that the hypotenuse or the vector length is 36. So now I can take cosine of 70 is a over 36, and then sine of 70 is b over 36. So cross multiplying, a is equal to 36 cosine 70, which is approximately 12.3. B is 36 sine 70, which is approximately 33.8. And now we have to account for the direction, which is left 12.3 or negative 12.3, and down negative 33.8, which allows us to have a resultant or a hypotenuse of the vector is 36. On example 4, it says to find the resultant of vector u, which is negative 4, 1, okay, which I show on my picture there, as starting at the origin, going left 4 and up 1, and then plus v, which from there is going 6 right and up 3, so you see v indicated, and the resultant of that from the origin left to the arrowhead, and from the arrowhead there to the right up to the end of the two vectors added, which then the resultant is from the origin where they two started up to r, up to the tip of the v vector, which is 2, 4. Because when I add components of u plus v, I have negative 4, 1 plus 6, 3. So I add the x components together. Negative 4 plus 6 is 2. And I add the y components together. 1 plus 3 is 4. And I'm just showing you how u goes to the left, 4 and up 1. V goes from there, right 6 and up 3. And r meets the end of v at over 2, right 2, up 4, which it has to. Now, example 5, given u is 2, negative 4, and v is 1, negative 3, find 1/2 u minus v. So we just take 1/2 of the u coordinates, both x and y, so 1/2 of 2 minus 4 minus 1 minus 3 is 1, negative 2, minus 1, negative 3, so we'll subtract the x and y coordinates. The x coordinates subtracted are 1 minus 1 or 0, and the y coordinates are negative 2 minus a negative 3, or negative 2 plus 3, or 1. So the resultant is 0, 1. Now in example 6, a small seaplane flies at an airspeed of 230 miles per hour due north, which is straight up, and that's shown in the picture. A steady wind is blowing from the west at 45 miles an hour. That's shown at the top of the 230 mile per hour vector to the north, so it's going to have a resultant r, which is the combination of the north vector the planes travel plus the wind. So the wind is going to pull it off course some. So the resultant vector, or the hypotenuse, is the square root of 230 squared plus 45 squared, which comes out to approximately 234.4 miles per hour. And the inverse tangent, remember, would be 230 over 45, because I'm bringing 45 from up top straight down to the bottom, and 230 from the straight up to over to the parallel to get alpha to have an opposite and adjacent. So alpha is equal to the tangent inverse of 230 over 45, approximately 78.9. So the plane is traveling at a 234.4 miles per hour at 78.9 north of east, okay? So that's north from east. So I'm going up from the x-axis, 78.9, which is in the north direction, from east to the right. So what we're doing is just showing you that there's several different ways of describing vectors. We've done about 3 different ways, and they all mean the same thing. Now the homework starts on page 599, and for problem 2, all we have to do is identify that v from the where it is printed on the homework page is 0, 3. And x is 2, 3. They have several vectors there, and they want us to give the direction. the components. So on 6, we have a base of 4 and a leg of 2. So we're going to find the resultant u vector in the alpha. So u, the right angle hypotenuse, is square root of 4 squared plus 2 squared, is the square root of 16 plus 4 is 20, is equal to the square root of 4 times the square root of 5, or 2 square roots of 5, which is approximately 4.5. And u has a alpha of tangent inverse of opposite 2, the down 2 over 4, which is 26.6 degrees. So here we go back to describing it this way, that u is 4.5 magnitude at 26.6 degrees below the positive x-axis. Now on 8, we have the legs of the triangle, right triangle, being 2 and 2. So the magnitude, or the hypotenuse, is square root of 2 squared plus 2 squared, square root of 8, or square root of 4 square root of 2, 2 square root of 2, or 2.8. And alpha is tangent inverse 2 over 2, or 45. You can notice that. Anytime tangent inverse comes out to 1, it's always 45. So vector W is 2.8 magnitude at 45 degrees above the negative x-axis. Now on 10, we have our 3, 4, 5 right triangle, if you recognize it. So the vector y has a hypotenuse of square root of 3 squared plus 4 squared, square root of 9 plus 16, square root of 25 equals 5. So its length is 5, and its alpha is tangent inverse of 4 over 3, or 53.1 degrees. So we can describe the vector y as 5 at 53.1 degrees below the negative x-axis. Now on 12, we have 5 at 45 degrees above the negative x-axis, and so therefore we can give it sides a and b and say that cosine 45 is b over 5 and sine 45 is a over 5, and we'll get the same numbers just with different signs. So cross multiplying, b is 5 cosine 45, or 3.5, a is 5 sine 45, or 3.5. They're the same, because it's a 45, 45, 90 triangle. But now we have to count for the fact that it's left 3.5 and up 3.5, because it's going in quadrant 2. Now 14 has what we would say is 25 degrees east of north would be what we've been given, so that we could make that complementary inside the triangle there as 65. And then it would have a magnitude of 10 for the vector, and with sides a and b we do the same thing as above. So cosine 65 is a over 10, and sine 65 is b over 10. A is 10 cosine 65, approximately 4.2. B is 10 sine 65, approximately 9.1. So our vector is going 4.2 right and 9.1 up in quadrant 1. Okay, in problem 16, we have a base of 5 and a side of 3. So this is going left 5, up 3. The hypotenuse is the square root of 5 squared plus 3 squared, or the square root of 25 plus 9, equals the square root of 34, or approximately 5.8. Now alpha, the direction, is the tangent inverse of 3 over 5, which is approximately 31. So we can say that r, the resultant vector, is 5.8 at 31 degrees up from west. So 31 degrees north up from west to the left on the x-axis. Now in 18, 19, and 20, we're going to be working with these 4 vectors. S is 2 to the right, 3 up. T is 2 to the right, none up. V is 3 to the right, 3 down. And V is negative, or 4 to the left, and then down 1. You can see that. Okay, negative 1. So u plus v, taking the coordinates, are 3 comma negative 3 plus negative 4 comma negative 1. Now adding x components, we have 3 minus 4, which is negative 1, and y components is negative 3 plus a negative 1, negative 3 plus a negative 1, which should be, negative 4, okay? So u plus v adds together component-wise to negative 1 comma negative 4. Now u plus s, taking the components to be 3 comma negative 3 plus 2 comma 3, this adds easily as 3 plus 2 for the x, which is 5, and negative 3 plus 3 for the y, which is 0, giving us a final answer of negative or positive 5 comma 0. And adding s plus v plus t, looking up at the top where they came from, we have 2, 3 for s, negative 4, negative 1 for v, and 2, 0 for t, and negative 4, negative 1 for v. Okay, so s plus v plus t. So adding the x components, we have 2 minus 4 plus 2, or 0, for the x component, and for the y we have 3 minus 1 plus 0, or 2. So that all adds up to 0, 2. Now for 24, we have f vector is 3 up and 3 to the right, as shown in the drawing, and if we subtract the g vector subtract h rather, which is minus 1, 4, you can see that we're going to subtract minus 1, 4, which means we add 1 and subtract 4. So from the 3, 3 end of vector f, we're going to go right 1 and down 4. So here we have it as 3 minus a negative 1 for the x components, or 4, and 3 minus 4 because we're subtracting minus 1. So we end up at 4 minus 1, and that allows me to draw the resultant r from the origin to 4 minus 1. That's how those two vectors subtract. Now on 26, we're asked to draw out what 3g plus 1/2 h is when g is 2, negative 1, and h is negative 1, 4, the same as above vectors. So here, if you see in the drawing, we go 1g, which is 2, negative 1, another g, the second g, brings us to 4, negative 2, and the third g brings us to 6, negative 3. Now if we go up 1/2, negative 1, 4, that means we're going plus negative 1/2, comma 2. So now we combine the x directions, and we have 6 minus 1/2, which I tried my best to show is 5.5, but it's going up negative 3 plus 2, so the resultant is at negative 1. So the end of the 3g plus 1/2 h should be at 5.5, negative 1, and that's what the drawing shows. Now, this is the end of our third week, our Friday. So now your homework 12.1, 12.2, 12.3, 12.4 is due today at 5. Now next week we're going to have a 4-day week only. We'll allow Friday as a free day to make up and get caught up if you're behind or sick or whatever. So we're going to keep the 4-day weeks as long as we are still on home learning. Thank you for doing such a good job on your homework and your tests. I really appreciate how well you've done during this disaster around the world. Keep yourself healthy and safe. Have a great weekend, and I'll see you on Monday. God bless.